Hey, good morning. It's Wednesday today and I'm recording it before class. Yes, look at me. That's awesome. All right, so I'm recording this video on 5.2. We partially did it, and the other half we're going to do today and tomorrow. We're trying to find values of 6 trig functions given a point or given a point or given an angle. So those two topics. This is the formula chart that I told you about. It's posted in Schoology. I printed it in my OneNote. All right, first topic. Let's say you're given a point. First of all, what are the 6 trig functions? Sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. We discussed this in class. Again, remember, none of these will make sense if I don't put that theta in front of it. And theta is basically representing an angle that we do not know yet. And for a generic term, we're going to put theta. The formula for these are sine theta is equivalent to, given a point will always have an x and a y coordinate. Sine theta equals y coordinate, cosine theta equals x coordinate. Tangent is the ratio of y over x. And these other three are inverses of sine, cosine, and tangent. So cosecant will be 1 over y, secant will be 1 over x, and cotangent will be x over y. These are the 6 trig functions. Given a point, I would want to find them. So let's say we are given a point, root 3 over 2, comma, half, and I have to find all 6 of these for them. Register in your mind, this is the x coordinate and this is the y coordinate. Using the formulas above, I should be able to calculate them. Cosecant, secant, and cotangent. All right. If you see above, sine is equivalent to the y coordinate. Y coordinate here is half, so this was simple, easy peasy. Cosine of theta is equivalent to x coordinate, so I get that as well. Tangent is the ratio of y over x. That would turn out to be half over root 3 over 2. A simple way is to cancel these denominators. They simply cancel each other out. This equals 1 over root 3. But if you remember, we discussed that the radicals are not acceptable in the denominator. So to take care of that, I'm going to multiply this fraction by the radical that's in the denominator. And what happens is, now when I multiply top with top, I end up with root 3. When I multiply bottom with bottom, root 3 times root 3 is simply 3. And I have gotten rid of the radical in the denominator. Coming back to cosecant, the formula is 1 over y. There are 2 ways to do this. You can either put 1 over and y is half, and then we end up with a fraction within a fraction. Or the other way is, if you have sine theta figured out, then you can simply switch sine theta, make it 2 over 1, which is the same as 2. Because cosecant is inverse of sine. And I'll do the same thing with secant. When I swap cosine, this value right here, I end up with this. And when I swap this one, I end up with 3 over root 3. And both of these again end up having radicals in the denominator. I can take care of them by simply multiplying with the same number in the denominator. When I multiply top with top, I get this. Root 3 times root 3 is 3. And you do not need to multiply the 2 and the root 3. You can just leave it right there. I'll do the exact same thing here. Top times top, bottom times bottom. So I have 1, 2, 3, 4, 5, 6 trig functions calculated for the point that was given to me. All right. Let me show you another example. Okay, let's pick any point from here. Again, remember the inner circle. The circle is a circle of degrees, the circle of radians, and all these are the coordinate points on that circle, right? Okay, so let's pick any point. Let's say we pick this point, the most odd looking point. Negative half, negative 3, root 3 over 2. right, which is corresponding to that radian and that particular degree. Negative half, negative root 3. So given a point, negative half, negative root 3 over 2. I have to find all 6 trig functions. Tangent, cosecant, secant, and cotangent. All right. And the formula is given in this first one, right? Sine is equivalent to yx. So this is your x coordinate, y coordinate, negative root 3 over 2. That's not bad. This is equivalent to the x coordinate, which is equal to negative half. Now tangent is y over 2. So negative root 3 over 2 over negative half. Okay, now when we divide two negatives, that turns into positive. And as I expressed earlier, if the denominators of both the fractions are the same, you can go ahead and cancel them. This turns out to be just root 3 over 1. Coming to cosecant, cosecant is inverse of sine. You can either go x over, it's not x over, it is 1 over y. So you can either go 1 over y, but then you will end up with fraction within a fraction, or you can simply take sine theta and swap find the reciprocal of it. Don't forget the negative. The negative doesn't get dropped. Now the only little issue here is that we have a radical in the denominator, so I'm going to take care of that by multiplying by that same radical. Root 3 times root 3 is simply 3. Alright. Secant theta is 1 over x. Again, you can either do that or just simply swap the value of cosine theta. Don't forget the negative. Negative is going to stay in the answer. And when you flip or find the reciprocal of negative half, it's simply 2. One last one. This would be technically x over y, but I don't want to go through all of this. So I'm just going to take the value of tangent theta. Now remember, this is by default over 1. I can flip that, find the reciprocal, and the same little issue, I end up with radical in the denominator, and I will take care of it the same way. There we go. They asked me for 6 trig functions, and I like to do them in a box so that everything is contained and symmetric. So sine theta, cosine theta is negative half, tangent theta, cosecant theta value is this, and then cotangent and secant are right there. I found it. Our topic 2 is very similar actually. Let's say you were asked to find all 6 trig functions, but instead of giving a point, they might give you an angle. So for example, find all 6 trig functions when theta equals pi over 4. So I'm like, huh? Theta is given. They didn't give me a point. But theta equals pi over 4 can be found on the unit circle. So like, what's the corresponding point for that? Again, remember, this is the origin, so this is 0, 0, right? And the radius of the circle is 1. Pi over 4 is right there. So they are basically asking me to find 6 trig functions of pi over 4. The corresponding point to that is root 2 over 2, comma, root 2 over 2. Right? So I can go to the unit circle and I can get the corresponding point for that. So I'm like, okay. The corresponding point here is root 2 over 2 and root 2 over 2. Once I have the corresponding point, then it's pretty much the same thing, right? I repeat the process because I know my 6 trig functions. Cosine, tangent, cosecant, secant, and I know I keep repeating them so that you kind of get used to what they stand for. Sine, cosine, tangent you're familiar with. The other 3 probably not as much. Again, remember, this is equivalent to the y coordinate, so root 2 over 2. This is equivalent to the x coordinate, root 2 over 2 again. Now tangent is y over x. Let me scoot this to the left. Tangent is y over x. Y is root 2 over 2 divided by root 2 over 2. And it looks complicated, guys, but listen, what? You know what's the easiest part here? We're dividing with the same, the numerator and the denominator are the exact same. It's kind of like dividing 5 over 5. What does that equal? We all know, 1, right? Kind of like dividing 54 over 54. It's going to be 1. So no matter what the numerator and denominator are, if they are the exact same, they all cancel out to simply 1. So tangent here is simply 1. Not bad, right? Cosecant now is basically 1 over y. Now you can go ahead and find the reciprocal of that, flip it over, so that's that, except now I have radical in the denominator, so I'm going to quickly take care of that. Root 2 times root 2 is simply 2. Secant is 1 over x, or you can flip cosine theta, that's 2 over root 2, and little same issue, but I can quickly take care of it. Root 2 times root 2 is 2, and cotangent is, flipping over 1, which we all know, flip over 1, reciprocal of 1 is 1. And I have found all 6 of them: sine theta, cosine, tangent, cosecant, secant, and cotangent, and they're all mathematically acceptable. No radicals in the denominator. We never changed them to decimals. That's how it is. All right. I mean, and we can come up with a lot of examples. If I say, hey, find me all 6 trig functions for, let's say, when theta is negative 225. Okay, let's do positive first. 225 degrees. So this is degrees, right? So go find 225 degrees on the unit circle. And this is degrees, so right here. And get the corresponding point. Right? And once you have the corresponding point, you know what to do. Boom, boom. All right. See you in class. That's it for 5.2. Bye.